This is our homework from Practice and Problem Solving 179 to 180. Number 1, it says the sum of two numbers is 27. One of the numbers is 3 more than the other number. Write and solve a system of equations to find the two numbers. So remember that a system is 2 or more equations. So the first equation will be the sum of two numbers is 27. Remember, the word is represents our equal sign. So I'm going to use x and y to represent the two numbers that we need to solve for. The sum, which represents addition, is going to be used. X plus y equals 27. So there's one equation. One number is 3 more than the other number. There's my second equation right there. One number is 3 more than the other number. So I'm going to use x and y as my two numbers, and I'm going to say x is, remember is represents your equal sign, 3 more than is addition, so 3 more than the other number. Then I notice that 1 is in standard form, 1 is almost in slope-intercept form. I could have easily wrote this as y equals 3 plus x, if that would help, because I know a lot of you are really good with slope-intercept form. And I can use substitution to solve the system. I can say that 3 plus x equals y. So I'm going to substitute that in for y. So I've got x plus y equals 27. And instead of y, I'm going to put in a 3 plus x. We really don't need the parentheses because we don't have distributive property. There's nothing that we need to distribute inside. So we're just going to go ahead and combine like terms. That gives me 2x plus 3 equals 27. Subtract 3 from both sides. 2x gives me 24. Divide by 2, and x gives me 12. So 12 is one of the numbers. 3 more than 12 will give me 15. So y would be 15. So my two numbers would be 12 and 15. You can put those in ordered pairs, but we really don't need to. Number 2, Roberta has $4 in dimes and quarters. She has 5 more dimes than quarters. Write a system of equations that you could use to find how many dimes and quarters she has. All right, so there's my sentence with money. Remember, you always want to have your money together in this one. We could use D for dimes and Q for quarters, or you could use X for dimes and Y for quarters. So if I start out using money, a couple of ways we could do this. Dime is worth 10 cents. So 10 cents for each dime. I don't know how many dimes we have, but I do know that a dime is 10 cents. Plus a quarter is 25 cents. And that is a total of $4. My second equation, it says she has 5 more dimes than quarters. She has 5 more dimes than quarters. So dimes, she has 5 more dimes than quarters, so D equals Q plus 5. She has 5 more dimes than quarters. So your dimes are your quarters plus 5. She's got 5 more. And And it just says to create a system. It doesn't say that we could solve for it. So we can stop right there. It says choose a variable for the number of dimes and a variable for the number of quarters. We use D and Q. Lots of ways that we could do this. I could multiply everything by 10 to get rid of the decimal. Or just leave it like that. Let's go on to number 3. It says use the system of equations you wrote in problem 2 to find how many dimes and quarters Roberta has. Okay, so we're just going to solve it down here. So we got to figure out how many dimes and how many quarters. Dennis chose A. How did he get that answer? Check your solution in the equation. I'm going to grab a sheet of paper because I don't see enough room to work this out. So I'm going to take these equations up here. I've got 0.10D plus 0.25Q equals $4. I really don't need that decimal and the 2 zeros. And then I've got dimes equals quarters plus 5. So this one looks like slope-intercept form, so I'm going to use substitution. This equals D, so it's going in for D. 10 or 0.10 times D plus a quarter times Q equals 4. Plug in Q plus 5. Use your distributive property to distribute in a dime. So we have 0.10 times Q. 0.10 times 5 is just 0.5. Bring down your 0.25Q equals 4. Try to keep everything nice and neat. Combine like terms. A quarter and a dime, that'll give us 35 cents. Plus a nickel equals $4. Subtract, I'm sorry, not a nickel, 50 cents. Subtract 0.5, which is a half. These are opposites, they cancel out. 0.35Q. 4 take away a half will be 3.5. Divide by 0.35. Divide by 0.35. And you can use a calculator. 3.5 divided by 0.35 gives you 10. So that means we have 10 quarters. We have 10 quarters. Well, remember, we have 5 more dimes. So that means for dimes, I have 15 dimes. 15 dimes, 10 quarters. Go back to our answer choices. 15 dimes, 10 quarters. So we should get C there. Now, Dennis chose A. I wonder what Dennis was thinking. If we didn't keep our variables straight in our problem, we could have easily thought that maybe this was dimes, and maybe that's what Dennis was thinking, that maybe this was dimes and this was quarters, because he chose A, so he probably got his variables mixed up. Let's go on and look at number 4. Line A passes through -3, -2, and 0, -4. Line B passes through points -2, -3, and 0, 1. Tell whether each statement is true or false. Line A and B intersect. Lines A and B have different slopes. Lines A and B have different y-intercepts. Lines A and B are parallel. So a lot of these questions we can answer just knowing what the slope is. So your slope formula is your second y minus your first y over second x minus your first x, excuse me. So we could also graph these and you could tell some of the answers. So if I use my slope formula here, I'm going to grab my notebook paper again. And let's say for line A, I've got -3, -2, 0, and 4. This is my first x, this is my first y, this is my second x, this is my second y. Use that formula up there. Second y minus your first y. Second x minus your first x. Two negatives give me a positive. So that's 4 plus 2, which is 6. Two negatives give me a positive, so that's a positive 3. Divide by 3, that gives me 2. So for line A, my slope is 2. Then let's go ahead and figure out the slope for line B. Line B, I've got -2, -3, and 0 and 1. Use the same formula up here, the second y minus first y over second x minus first x. So this is my first x, this is my first y, this is my second x, this is my second y. And I've got 1 minus -3, 0 minus -2. Two negatives make a positive, so that's 1 plus 3, which gives me 4. Two negatives make a positive again, so I'm dividing it by 2, and I'm getting 2 again. So we have the same slopes, and hopefully you remember that if you have the same slopes, they are going to be parallel. Now, what we don't know, but here's a great little hint over here. Remember that the y-intercept is the y-coordinate when x is 0. So right here, I know what my y-intercept is. And I know what my y-intercept here is. I could even put these in slope-intercept form. Y equals 2x plus 4. Y equals 2x plus 1. Oh, that, you can't see that. Let's see if I can move that. Make it a little bit. Put it up here. Y equals 2x plus 1. So here we've got the same slopes as 2, but I have different y-intercepts. 1 is 4, 1 is 1. Oh, love these little hints right here. So I know that they are parallel, and if they're parallel, they will have no solution. Let's see if we can answer these questions. Lines A and B intersect. No, not if they're parallel. Lines A and B have different slopes. No, they have the same slopes. Lines A and B have different y-intercepts. Yes, they do. Lines A and B are parallel. Absolutely, yes. And question 5. Question 5 has 2 parts to it. Let's look at the first part. The Parks and Recreation Department in your town offers a season pass for $150. With the season pass, you pay $5 per session to use the tennis courts. Without the season pass, you pay $15 per session to use the tennis courts. Now I'm going to read this little over here. I'm sure this will be a good hint. What does the point where the lines intersect represent? Okay, so we're going to figure out where they're going to intersect. I'm going to take me some paper and let's set up our system. All right, so we've got 2 options. You're either going to get the season pass or you're not going to get the season pass. If I'm going to get the season pass, all right, so we're going to have one with a pass and without the pass. All right, so with the pass, that means that we are starting out paying $150. So that's going to be my slope, my y-intercept. It's going to be my starting point. With the pass, I'm paying $5 per session. So that's my rate. That's my slope. Without the pass, I'm not going to be paying the $150. However, I'm going to be paying $15 for each time that I want to use the tennis courts. Part A, write a system to represent the situation. So there's our system. We could use different variables. They don't tell us what to use here. So I've got y equals 5x plus 150 and y equals 15 times x. Now, we want to define what your variables are. So x represents your tennis session. Y represents your total cost. Part B, graph the system. Graph the system. I would not have chose graph. I probably would have done substitution, but I see this lovely graph here. Graph your system of equations. How many times do you need to use the tennis courts for the season pass to have the same money? Oh, I'm sorry. How many times do you need to use the tennis courts for the season pass to save you money? Interesting question. Save you money. Okay, so I'm going to start down here, and it looks like they want you to use S and C. We didn't do that. That's okay. So if I start here at 0, I need to go up 15. Well, I don't have 15 for my units. So let's think about my slope being 15 over 1. If I multiplied that by 2, that would give me 30 over 2. I still don't have 30. If I multiplied it by 3, 15 times 3 would give me 45 over 3. So notice that these go by 5. So I wonder if 15 times 5 would give me 75 over 5. So I can go up 75 and over 5. So 75 over 5 is just an equivalent fraction that reduces down to 15 over 1. So that helps me with these increments that I'm given. So up 75, let's see, 25, 50, 75 over 5. So that's 3 blocks up, 1 block over. 3 blocks up, 1 block over. 3 blocks up, 1 block over. So here we have our line that represents no pass. So this is no season pass. And then I'm going to take a different color, and I'm going to start out at 150, and I'm going up increments of 5. So my slope is 5 over 1. These do not go up 5, they go up 25. So I'm thinking I could multiply 5 and get 25 over 5. 25 over 5 gives us 5, so I can go up 25 over 5, up 25 over 5, up 25. There's where they cross. But I don't want to know where they cross. I want to know how many times do you need to use the tennis courts for the season pass to save you money. So the blue line is no season pass, but the red line is your season pass. So it looks like right here, it would cost the same if I had 15 sessions. However, if I did 16 sessions, 17 sessions, 18, 19, 20, and so forth, it would save me money. It's below the blue line. So I would have to say 16 times. 16 times it would start saving me money. At 15, which is where they equal, it's not going to save me money. But at 16 times, it's going to start saving me money. So we could go on and explain that at 16, so if I plug in 16 for these equations, 5 times 16 plus 150 gives me 230. So that's with the season pass. That is $230. Without the season pass, then I would do 15 times 16, which is 240. So you got to think about it. Am I going to be playing tennis a lot? Am I going to play more than 16 times? What would be the better value for me?